I like to take a selfie before I speak, so I hope that's okay. I'll block out everyone's faces in my Insta story. Thank you for indulging me. So the title of my talk is Drawing Circles 3 Ways, Generating Graphics for the Web. I am Amy Cheng. I am a web developer for New York Magazine. And what do I mean by generating graphics for the web? Well, in this talk, I'm going to sort of show how we can use code instead of image files to create visual elements on a web page. In the near past, about 10 to 15 years ago, we had to use things like Java and ActionScript to dynamically generate visual elements on a web page. Sometimes this required the developers to use a third-party application like Macromedia, Flash, /Director. Almost always, we required the user to download a third-party plugin. Now, most of the time, the users will click on that dialog saying, okay, I'm going to wait and download this third-party plugin to view this thing you want to show me. Other times, users might be like, no, this looks really scary to me. You might be downloading a virus, so I'm not going to click on this dialog. Or they might be on a computer that has a restrictive IT policy. Nowadays, we can rely on native browser APIs like CSS, SVGs, Canvas, a couple of JavaScript to create visual elements. And we do not need to require the user to opt into downloading extra scripts because all of these runtimes, the browser renders CSS natively, understands SVG, understands JavaScript out of the box. So the first approach I'm going to talk about is CSS. Most of the time, almost all the time, we use CSS to decorate our markup. In this approach, we're going to use CSS to create shapes. So we'll need a DOM element, most likely a div tag, and we're going to use the CSS property border radius to create this circle. So here's our CSS code. We have a background color of red, border radius of 50%, and we're setting our circle to be 100 pixels tall, 100 pixels wide. And our way of thinking about this is we want to create a circle that has a radius of 50 pixels. Now, where does border radius come in? Well, divs are a box. They're a square, they're a rectangle. And setting the border radius to 50, we're kind of curving the border so much that it ends up being a quarter of our circle. So this is what the markup would look like. CSS circle is our selector. Now we're going to animate our circle. So this is what it's going to look like. Play that again. And this is our CSS. So we have a keyframes block and the animate selector. What we're doing in this keyframes block is that we're defining significant events in our animation. Those of you who are familiar with sort of the animation terminology, a keyframe is an important frame where something happens, and then an animator has to sort of draw each frame that goes from one important event to another to sort of create this seamless motion. So going back to the animate block, we have the animation property. We're telling the browser, hey, our animation is position, which we've defined in the keyframes block. We want our animation to be 5 seconds in duration. And even though it's 5 seconds long, we want to loop this animation indefinitely. So going back to the keyframes block, you see percentages. These percentages refer to the spot in the animation length. So 0 and 100% refer to the start and the beginning. 50% refers to the halfway point of our 5-second animation. So at the start and end of our animation, we want the margin left of our circle to be 0. This creates the effect of the margin being, the circle being on the farmost left side of our web page, or of the width of where we've defined it. Then 50%, about halfway in the animation, we want our margin left to be all the way to the right. You'll notice something funny here. Instead of setting it to 100%, I have it set as 100% minus the width of our circle. I did it this way so our circle will not be cut off at the edge of the page. And we're telling the browser to make room for our circle. Now, the advantage of this approach is that it scales and is responsive, assuming that you're using relative units. If you use absolute units like I did in the example, it will stay at 100 pixels no matter how big or small the browser is set to. And also, another advantage of this approach is that the browser is figuring out in between frames. So you basically told the browser, I want our circle to be here, 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 and you figure out what you have to draw to make it seem like that the circle is moving. This is a reminder of what the CSS looks like. Now, I consider this approach kind of hacky because when you look at this, besides assuming, well, let's assume the developer you're working with did not use this selector and has used something totally random. How can you tell that this is a circle unless you have the knowledge that, oh, there's this border radius at 50%. They are trying to create a circle. It does not really match a mental model of what a circle is. When we think of circles, when we envision it, do you really think of circles as having borders? So that kind of makes this block less grokkable. You're also creating a contentless DOM element, which means you have a div, but there's no content within that div. And that is not great for accessibility. The next approach we're going to use to create the same exact circle is SVGs. Now, SVGs can also be embedded in a web page using the image source tag, but in this example, we're going to inline the XML. So we have an SVG parent element, and then a circle child. The circle looks almost exactly the same as our CSS circle, except maybe a little crisper. And here's our markup. So we have an SVG. We are setting the height and width to 100 pixels, and we're setting a child element. We're using a circle tag. This is going to be our circle. CXCY refers to the X and Y position within our SVG parent. So when we set the height and width in the SVG tag, we're telling the browser, hey, this is kind of my canvas. This is where I want to be drawing things. And this canvas is restricted to 100 pixels by 100 pixels. And the CX and CY attributes, as I said before, refer to X and Y position. So I am telling the browser to draw this circle 50 pixels to the right and 50 pixels from the top. R stands for radius. Then we have stroke width and fill red. For our purposes, stroke width doesn't really matter. It's just how big we want our border, but since our border is going to be red, we can't really tell that our circle has this outline. Fill red refers to our background color property that we set for our CSS circle. Next, we're going to animate it by adding the animate selector, which we defined a couple of slides ago. It is exactly the same because we are using CSS animation to animate our SVG circle. Now, the advantage is that, like CSS, as long as you're using relative units, it scales and is responsive and is totally beautiful no matter what the browser size is. The XML, this is a fun one, can be exported from a third-party software. So you can work with artists, visual designers, and they can use their tools, such as Illustrator, and give you this beautiful graphic, and then you can inline that into your markup. Disadvantage is that the animation is not an SVG API. You're still relying on CSS to give you animation. The markup can be bloated when you export it from Adobe Illustrator. You can minify your SVG in using gulp, grunt in your post process, but that's another step you're going to have to remember to do. Next, we're going to use the Canvas API. Coupled with JavaScript. Now, if you define a canvas element on your web page and don't write the accompanying JavaScript, you'll just have a blank page. You will need to write JavaScript to sort of access the HTML5 API for creating graphics within this canvas element. You notice here that it's a little blurrier compared to the CSS and SVG circle. It's because the canvas element is an HTML5 API for creating bitmap graphics. SVG stands for Scalable Vector Graphics. So an SVG file the browser reads it as a series of mathematical calculations that it needs to run to determine what to draw at each pixel. Bitmap graphics, like this one here, JPEGs, GIFs, PNGs, I think, it's a file format that has data for each pixel point. Now, when you scale a bitmap graphic up and down, our browser is trying to make a best guess as to like, okay, what pixel data do I have to remove? What pixel data do I have to add? And a lot of the time, the browser makes a bad guess, resulting in blurry images, pixelated images, images that don't look as crisp as the original file format. Whereas with SVGs, the browser is given this mathematical calculation, okay, and will always get and can recalculate each pixel more accurately, resulting in crisper images. So assume that we have defined a canvas element, canvas DOM element with the ID of static canvas circle, and we are using JavaScript to target that element. In this second line after we define our static circle function, we have ctx equals c.getContext2d. This is essentially our code asking the browser, hey, telling the browser, hey, I'm about to create a 2D graphic or a 2D image, so prepare yourself. You can set this to 3D, and this will trigger GPU acceleration because 3D graphics presumably have a lot more things going on, and the CPU can't really handle it in a fast enough way. But that could be an entirely different talk. So here we have CTX, which stands for context, dot begin path, arc, stroke style, stroke, fill style, fill. You'll notice that this code is a little bit more declarative, I would say. So we're telling the browser, hey, I'm about to begin drawing this circle. And this circle comprises of arcs. I also want our stroke, that is the outline of the circle, to be red. Okay, my outline is red, so start drawing this outline. Also, I want my fill, my background color, to be red, and then color it in. Arc, the first and second arguments define the XY position of our circle. So 50 pixels from the left, and 50 pixels from the top. The third argument stands for radius, and the last two is sort of where we start and end our arc. So 0 stands for 0 degrees. 2 times math.pi basically equals 360 degrees. So we draw an arc, and it ends up becoming a circle. Now here is a preview of the code we need to write to animate our circle. You'll notice that it is not as snappy as our SVG and CSS circle. It is because in CSS animation, by default, our browser has figured out our tweening for us. What that means, the default tweening function is easing, which means that the browser will sort of accelerate our animation and decelerate it at the beginning and end of the animation. And this ends up creating a very natural-looking circle. Whereas with our JavaScript, we do not have that out of the box, and we would need to define it by ourselves. So in this code, a few changes. We have position x as a variable, and we have a direction variable. We'll get back to that later. So we have a rectangle here. We are creating a rectangle at each step of the animation because we do not want to see echoes of a moving circle. If we do not have clear rectangle, fill style white, stroke style white, we'll see sort of the circle move across the screen, but we'll all see its previous states also. So we are using the position x variable in our arc method, and then we have some conditionals over here. So these conditionals are basically what creates the back and forth. So if the position of our circle is more than 800 pixels, 800 pixels is a totally arbitrary number, by the way. So if our circle moves beyond the bounds of 800 pixels, we want it to go back to the start. But if it goes back so far that it is off the page, we want it to go back in that direction. And this will happen each time request animation frame is executed. So the name of this entire function is called animated circle. And what request animation frame does is that it executes this function for each frame. The default frame rate for browsers is 60 frames per second. So presumably, if you have a computer that isn't bogged down by other things, it will run this function 60 times per second. Your frame rate could drop if you have a lot more calculations happening, if you have a lot more other things happening on your web page, so be aware of that. As I mentioned before, we do not have default tweening. It's because in this code we are telling our browser to draw our circle 1 pixel each step of the animation. Now, the disadvantages of this approach seem really apparent. The code is way more verbose than the CSS and SVG approaches. When we think of circles, we really think of them as arcs. The SVG API is more accessible because it says circle, whereas this is an arc. The image quality is not as great. It's bitmap graphics, and there's no tweening default. So we have to somehow figure out how we can accelerate and decelerate our circle at the correct times. But JavaScript is super powerful, and we can use it to code complex behaviors, like this one. These are a bunch of circles. They seem kind of alive. That is because each circle, I'm using JavaScript library called, I think, flocking.js. Sorry. And so what's happening here is that every circle has their own direction and the speed. They have their own direction and speed, but this is also tempered by its neighbor's direction and speed, and also where our mouse is. So you'll notice here that it's kind of grouping together around our mouse. So what's happening here is we're using JavaScript to calculate at every frame where each circle needs to be. It has a random direction, a random speed, but also takes into account everyone else's speed and direction, creating this flocking behavior, which looks totally way more natural than our previous circle moving along the line. Now, you're asking a few questions you can ask yourself, and the answers will kind of determine which approach you can use. It's also important to note you don't have to choose one over the other. It really depends what you're trying to do. Are you creating user interfaces? Are you creating data visualizations? Are you creating animations? Is performance a concern? So here is a screenshot of a material design library. It is a library for React components. The bell is an SVG graphic, whereas the circle is a CSS circle. Now, material design is, I don't know quite how to describe it. Material design is kind of like Google's design suggestions for their own apps and for Android apps. Here we have a screenshot of a data visualization example. This is from the d3.js library, a very popular library for creating data visualizations. And the source code is on, I guess, my left, your right. And you'll see that every single circle is an SVG graphic. What D3 does is pretty clever. You just kind of like jQuery for data visualization. So it just takes in data, which could either be in a JSON or CSV format. Others have created sort of libraries to make other data formats more parsable to D3. And so it takes each data point and creates an SVG graphic for each of them. Here, We have screenshots from Chrome Dev Tools. I did a performance audit of CSS animation, comparing it to the Canvas/JavaScript animation. Sorry, so my left, your left is CSS, and the other is JavaScript. You'll notice that for the CSS animation, we're doing a lot of recalculating of style. Lots of energy is spent to recalculating layout, which makes sense because what CSS animation does is just is moving the div every so often. And so each time a div is moved, we have to figure out where other things on the page fit to accommodate that div. You'll see in the JavaScript audit that we're not really doing all that because all that animation is done by JavaScript. We're not reordering elements on the page. And so we're spending no time at all recalculating styles and layouts. However, so what I did here, this is for CSS animation, and I am looking at the first 4 seconds of runtime. So a lot of time is spent. The purple represents layout, anything related to CSS. A lot of time and energy is spent recalculating style. But in JavaScript, even though we're not spending a lot of time recalculating, figuring out layout, we are spending some resources on JavaScript. Now, I find that sort of with these tools available to web developers that there is a missed opportunity with working with non-web developers because tools like CSS, SVG, Canvas, JavaScript sort of gives us more ways to discuss, hey, how do we create visual elements with people who might not be as technically aware or who are not developers, but can still contribute a lot to how we create these visual elements on the page. So for example, I would suggest you can use sort of these tools as an opportunity for collaboration to figure out which approach is best for your project. So you can talk to a data scientist to figure out, hey, maybe a circle isn't the best way to visualize this information. What other shapes, what other colors, what kind of dynamic animations can we use for this data viz that we're thinking of creating? Visual designers could create SVGs for you. So instead of you trying to fumble around with the SVG API library, trying to figure out which markup goes with which arc or line, you can ask the visual designer to create it for you in Illustrator. People who are in motion graphics could give you lots of feedback on tweening functions, on how you should time your animation to make it look more natural, more engaging. If you look at the Google Material Design docs, they even have sort of guidelines on the best animation timing functions to use to create snappy-looking user interfaces. And that's all I got. Thanks.
Awesome. So we've got a few moments for a few questions. Maybe to kick things off, you were talking about SVG animations and that the APIs aren't standard. Are there browser implications to the SVG animations that for standard support?
Not really. There are like popular libraries that do SVG animation, like Raphael.js. But what they're doing is what CSS is doing, is just basically moving this SVG element back and forth whichever way, and that will cause like CSS style recalculations, layout recalculations. But people do want to pay that price because SVG animation is so crisp and great and scalable. So they will take that hit in performance if it, I mean, it will require trust on the end user. You're kind of betting that the end user will wait for your totally awesome web page. So, but no, there really isn't. This is all like decisions like the community has made.
Cool.
It's always a tug and pull with performance versus like this awesome experience I want to give you, but you have to wait 5 seconds for it. But please wait 5 seconds for it.
Awesome. We've got a few moments here where we can grab some questions. One in the back here. There's a microphone that's going to come by so we can all hear the question.
Have you ever used green sock to animate your SVGs? And if you have, do you have an opinion about it?
I actually used GreenScock in my like Flash ActionScript days, and I found it as like a sort of a library that you can import into Macromedia. Macromedia Flasher Director, and I found it to be pretty easy to use. Like, it just gave me natural-looking animations out of the box, and I would assume it's the same for JavaScript. So I haven't used its JavaScript port, but the library, the documentation for it looks great.
Yeah, I've just used it and I really liked it, so just, yeah.
How would you compare font-based icons like Font Awesome versus using an SVG?
Well, actually, we're in the middle of a redesign at New York Magazine, and the problem with kind of like adding a font is that we're kind of like letting open the floodgates to our designers to keep adding more fonts into the data payload. There are tools where you could just pick out like specific icons or specific lips from fonts, and that's great for performance. But that's another build process. That's another thing to consider. And also your designers will be like, hey, you added this font, could you also add 2 other fonts? And you're like, well, is that a discussion you really want to have?
Good afternoon. Here's a quick question, just around the animation and the sort of accepted norm that we should be designing for or developing for mid to lower tier devices mobile. Have you done any testing around that area in some of these frameworks that some of these people are mentioning, and how that would impact rendering?
I haven't done any auditing, but a lot of the time developers will use a third-party animation library. So even though you could write these CSS animations by yourself, you could, the web developer community is like so generous. Everyone likes to create tools and just release them for free. So there are like a billion CSS animation libraries. So what these libraries do is that it uses JavaScript to script CSS animation. The performance is comparable to doing it by hand, but it also means you're making the end user download additional JavaScript. There really isn't best practices, because even though we have these, we've had these APIs, we've been doing this circle hack forever, it's just hard to articulate things like motion in a way that we've been articulating JavaScript toolkits. I mean, that's the way I see it. There isn't established conventions, and like, I think the material design sort of guidelines is kind of like the first instance of standardizing conventions for motion in user interfaces, but no big company, no open source project has really formed about like, hey, how should we animate these things? It's all been like experience. That's why I suggest like working with people who actually do motion graphics to kind of like help you design these experiences, because we're all kind of just fumbling around.
Awesome. Oh, is that a question? No, okay. Just a stretch. Awesome. Well, thank you very much, Amy.
Thank you.